Welcome back. We're going to keep solving trig equations. And in order to do that today, we're just going to keep in mind that you're going to have to use some of those trig identities that we've learned in order to simplify your equation in order to solve. So it says, look at the equation and determine whether an identity can be used to simplify the equation, and rewrite the equation and then solve. In identities, I want you to keep some of these in mind. The ones that you need to know really well. That's cosecant of theta, which is 1 over sine of theta, and secant of theta, which is 1 over the cosine of theta. So those two reciprocal ones are really important. You're going to use those quite a bit. Same with the tangent and the cotangent. So tangent of theta is equal to the sine of theta over the cosine of theta. And the cotangent of theta is cosine of theta over sine of theta. So we had gone over these identities quite a bit when we were verifying identities, but these are some that you're going to use quite a bit to solve equations. So make sure that you know those and know those well. The other ones that you're going to want to use are the Pythagorean Theorem ones that we use a lot. That's 1 minus sine squared of theta is equal to cosine squared of theta. And 1 minus cosine squared of theta, I have a little trouble with my lead here, cosine squared of theta is equal to the sine squared of theta. It's probably the most popular one, the one you use most often. So if you know no other ones, make sure you know those. And then we've got 1 plus tangent squared theta is equal to the secant squared theta. And 1 plus cotangent squared of theta is equal to the cosecant squared of theta. So those identities are the ones that we're going to use most often when we're solving. Make sure that you know them. That way you can identify them in the equation, simplify, and be able to solve. All right, so on this part here, it is telling us to use the interval between 0 and 2 pi. Notice that 2 pi does not have an equal sign, so we wouldn't want to use the actual 2 pi. All right, so we're solving here. Square root of 3 times sine of theta minus cosine of theta equals 0. The first thing I'm going to do is take that cosine of theta to the other side. And so we've got square root of 3 sine of theta is equal to cosine of theta. So I added the cosine to get it to the other side. Now I can divide by sine of theta, because since I know my identities well, I know that cosine of theta over sine of theta is going to give me the cotangent. So we get square root of 3 is equal to the cotangent of theta. Now it's an easy one to solve. Cotangent of theta we know is x over y. So we're looking for the x value over the y value. Since the square root of 3 is over 1, if you think about that, then we know that this had to be square root of 3 over 2 over 1/2. So we're looking for that point that has the x value of square root of 3 over 2 and the y value of 1/2. Since it is positive, I know we're talking about the ones that come out of this first and this third quadrant. We wouldn't want to use the second and fourth quadrants because then that would be a negative cotangent value. All right, so the thetas that give me that is pi over 6 in the first quadrant and 7 pi over 6 in the third quadrant. All right, for our second one here, I've got a sine on this side and I've got a cosine on this side. Now this one is squared, so I can use my identity for cosine squared to change that to be a 1 minus a sine squared of x. Now I've got the same trig function, sine of x and sine squared. So since it is a squared and a power to the first power, I can get it set equal to 0 so I can factor. That should always be what is in the back of your mind. So on this side here, I got 1 minus 3 sine of x. If I can get this all to one side, I can factor. I like to have my sine squared term positive, so I'm going to add this sine squared to get it to the other side. So I'm going to get sine squared x when I add this over, minus 3 sine x. And then when I subtract this 1 to get it to the other side, the 1 minus 1 is 0. So now I've got all my terms on one side. I am ready to factor. So we can factor out a sine x, since that's the GCF. And so sine x times sine x gives me that sine squared of x. And sine x times -3 gives me that -3 sine x. Now we're ready to set each one equal to 0. So I set sine of x equal to 0 and sine of x minus 3 equal to 0. Sine x equals 0. The only places where the y is 0 is at that 90 degrees, so that's pi over 2, and at 0, the y value is 0 at 0. And at pi. That's where our y value is 0. Now for our other part here, we're going to add 3, so we get sine x equals 3. Sine of x is never 3 on that unit circle, so we would say that's DNE, does not exist there. So my only solutions are the 0 and pi. All right, for our number 3 here, these are a little bit harder, this 3 and 4. We're going to try squeeze that in too to get everything in here. All right, I've got a cosine squared and a sine. Again, I want that to be the same trig function since there's a squared term and a first power term. So I'm going to trade out this cosine squared for 1 minus sine squared. And I'm sorry, there was a typo here, so make sure you change in your notes. That should not have been a 3, it should be a -1. So fix that on your notes there. That was a typo, that should be a -1. All right, now that we used our identity to get everything to have only signs, we notice that there's a squared term and a first power term. So we're going to go ahead and get that all together on one side. Again, I like it to be a positive sine squared, so I'm going to move everything to the right-hand side. So on my left-hand side, I'm going to be left with 0. I add the sine squared. I'm going to add the sine. And then I'm going to subtract this 1. So when I subtract the 1, -1 minus 1 is -2. Now we're ready to factor. This is a trinomial, so it's ready to go into the parentheses since the a value is 1. And so that's sine times sine gives me the squared term. And we're looking for what multiplies to be -2 and adds to be 1. And that is a +2 and a -1. Now we're ready to set each one equal to 0. So we get sine plus 2 is equal to 0. And sine minus 1 is equal to 0. I subtract the 2, so I get sine is equal to -2. That is out of our domain and range for the unit circle, so that would be a DNE. And then here I would add 1. And the only place that sine is 1 is going to be at pi over 2. So we've only got one solution on that particular problem. All right, for this next one, I've got sine, cosine, and tangent. Since I've got 3 different trig ones here, I'm going to try and get it down to 2. I know that tangent could be sine and cosine, so that's what I'm going to do. I get sine of x times cosine of x is equal to sine of x over cosine of x. Remember, tangent is sine over cosine. That's another one of those identities. That's why you want to know them really well so that you know where to start with that. All right, in order to get rid of this cosine x, I'm going to multiply both sides times cosine x. So I get 2 sine x cosine squared x equals sine x. So when I multiply both sides times that cosine, I get the squared here, and then it cancels on this side. Now I'm ready to bring that sine x to the other side. So I'm going to subtract that, and I get 2 sine x cosine squared x minus sine x equals 0. Now I can factor. I've got a greatest common factor of sine x there. So I'm going to factor that out, and I'm left with 2 cosine squared x minus 1. Remember, when you're factoring that GCF, all you're doing is undistributing. All right, so sine x equals 0, and 2 cosine squared x minus 1 equals 0. This side's easy. The only place y value is 0 is at 0 and pi, so we're done with that side. On this side, there's going to be a little bit more solving to do. So we're going to add that 1 and then divide by 2. And we get cosine squared x is equal to 1/2. I take the square root, and so I get cosine x. I'm not going to forget that plus or minus. The square root of 1 is 1. The square root of 2 is square root of 2. Of course, we never leave it like this, so we're going to rationalize that, and we get root 2 over 2, plus or minus. Don't forget that plus or minus. So now we need to think about all of our solutions that give us this plus or minus. There is going to be 4, since we've got the 2 cosines in 1 and 4 that are positive, and quadrants 2 and 3 that are negative. So all of the ones that will give it to us is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. There's our 4 for that. So this particular one had 6 different solutions. We've got these 4 here, and then the 2 that we had gotten before. All right, so let's talk about the sum and difference formulas. These are some on your formula chart as well, like some of the identities that we've talked about. This helps us to get exact values for some of the angles that we do not have on the unit circle. What we need to do is think through sine of u plus v is equal to this part right here. So if we can separate an angle into 2 angles that we do know, we're able to solve with that. So for example, 11 pi over 12. That is not on my unit circle. However, if I thought about separating these into 2 separate things that add up together to give me 11 pi over 12, it could work. So 9 pi over 12 plus 2 pi over 12, that will give me 11 pi over 12 if I add them together. And if I reduce these, I get 3 pi over 4 and pi over 6. Now those are on my unit circle, so I'm able to use those. So by converting them into these 2 plus, and then I can stretch it out, but I can't come up with exact values because those are on my unit circle. I want to show you a subtraction one as well. So for example, here, if we had 1 pi over 12, I can think of that as 4 pi over 12 minus 3 pi over 12, because the 4 pi minus 3 pi will give me the 1 pi up on top. And if I reduce this, that would give me pi over 3 minus pi over 4, which again are both on my unit circle. So you really want to think through those angles there to see what will give you something in the unit circle. And we're going to try some examples so you can see that. For example, number 1 shows us to find the exact value of cosine of 75. So I want to think through these 2 right here, the ones that I would want to use since they're cosine. So cosine of 75 degrees. And I want to think about 2 angles that would give me that 75 degrees, but are on my unit circle. Well, we can say that is the cosine of 135 minus 60, because that gives us cosine of 75. And these 2 are on my unit circle. So once I have them separated, so the 135 minus 60, which is this bottom one right here, I would set it up as the cosine of the first one times the cosine of the second one. So we're going to get cosine of 135 times the cosine of 60. And then we're going to do the sine of the first one and the sine of the second one. So sine of 135 times the sine of 60. And these you should know because they are on the unit circle. So cosine of 135, that's the x value of 135. That's going to be negative root 2 over 2. And then cosine of 60, that's 1/2. Sine of 135, that's root 2 over 2. And sine of 60, that's root 3 over 2. Now we multiply these two and multiply these two together. So when we multiply the numerator times the numerator. So that's going to be negative root 2, and then denominator times denominator, which is going to be 4. And here we multiply root 2 times root 3, which is root 6, and 2 times 2, which is 4. And so this would be negative root 2 plus root 6 over 4. There's the exact value. If you think you're ready to try that, go ahead and pause and try that sine of 105. If not, just follow along. And so we've got sine 105 would be 60 plus 45. Both of those are found on my unit circle, and they add up to be 105. And so now we're ready to use the formula. This is sine, so I'm going to use one of the top two, and it's addition here, so I'm going to use this one. So I do sine of the first one times cosine of the second one, plus cosine of the first one, sine of the second one. So here we go. That's going to be the sine of 60 times the cosine of 45, plus the cosine of 60 times the sine of 45. We get our ratios. Sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 60, that's 1/2. Sine of 45 is root 3 over 2. No, root 2 over 2. Now we're ready to multiply. And so that gives us root 6 over 4 plus root 2 over 4, which is root 6 plus root 2 over 4. All right, we got two more examples here to show you. These are going to be in radian, just so you can see what that looks like, because that's still the same thing. We're going to separate this one, the sine. We're looking for 11 pi over 12, which we did do already up on the top there. That was 3 pi over 4 plus pi over 6. Since this is sine, I would use the very top formula because it's plus. So we would use this one right here. And so I'm going to do sine of 3 pi over 4 times cosine of pi over 6 plus cosine of 3 pi over 4 times sine of pi over 6. Once we have that set up, it's just getting those ratios from the unit circle. So we've got root 2 over 2, root 3 over 2, negative root 2 over 2, and 1/2. I multiply. And so that is root 6 minus root 2 over 4. That's the exact value. All right, same thing with this one. We had done that up there, so we know that cosine is going to be the pi over 3 minus pi over 4. Since this is cosine, I'm going to set up this one. It was minus, so I'm going to go with this right here. So I do cosine of each plus sine of each. Once we set those up, then we come up with our ratios. And so that is 1/2 root 2 over 2 root 3 over 2, and root 2 over 2. We are getting the same numbers since we used basically the same ones, just switched around. And so that gives us root 2 over 4 plus root 6 over 4. And there's the exact value. All right, sometimes we can use these formulas to go backwards. Looking at this next one, we've got find the exact value for sine of 42, cosine of 12 minus cosine of 42 and sine of 12. Couple things you need to recognize. This is sine and cosine. So I know that it's going to be one of these top two. We've got the sine and cosine from that. So sine and cosine, because these are both the same. The other thing you should have recognized, the signs are different. So with the sine ones, they stay the same. With the cosine ones, they are the opposite. So you have to keep that in mind. So since this one is a sine cosine and separated by a minus, we know it comes from this one right here, sine u. So we would get the sine of 42 minus 12. Whoops, you can't see that. Sine of 42 minus 12, since that's my first angle and my second angle there, that gives me the sine of 30 degrees, which is on the unit circle, that is 1/2. We'll try another one of those, this last one here, find the exact value of this one. It is cosine, cosine, sine, sine, and there is a minus in between. So we come up here, cosine, cosine, sine, sine with a minus in between. That had to come from cosine, my first plus my second. So let's look at that. So we're going to do cosine of 25 plus 20. That is the cosine of 45 degrees. And at 45 degrees, it is root 2 over 2. So we have found the exact value there. So you can work that forward or backwards with those. Just get used to using those formulas. They're on the formula charts that you're going to get. You just need to get comfortable using them.